Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in the subject short range wireless communication. We're going to see super regenerative receiver. In previous video we have seen what is TRF receiver and what is ASH receiver, and today we're going to see the working of super regenerative receiver. And as I said in previous videos, receiver plays a very vital role in receiving the signal which is transmitted, right? And that determines the performance of any wireless link. And when we say receiver, the receiver capability will be identified or it will be evaluated upon two very important parameters. One is selectivity, another one is sensitivity, right? Selectivity is the ability of the receiver to select the appropriate signal, the desired signal among the mixture of signal. That is known as selectivity. We can also say that, we can also put it in other words like the ability of the receiver to reject all other signals and select the desired signal. That is called as selectivity. And what is sensitivity? The ability of the receiver to amplify the desired weak signal. That is called as sensitivity. And most of the receivers work in the same operation. That is where you will receive the signal and then you will convert that signal to an intermediate frequency using an oscillator, and then you will send that signal to a detector where you will reconstruct the original signal which is transmitted. That is the normal working of any particular receiver. But the receiver is classified or it is used for different application depending upon its selectivity and sensitivity, right? And when it comes to super regenerative receiver, super regenerative receiver is most commonly used receiver for garage door openers, security systems, and the very important advantage here is it has high sensitivity and it is very inexpensive and it has very minimum number of components. So these are the greatest advantage of super regenerative receiver, and very importantly this is considered as a high sensitivity receiver when compared to the other receiver, right? That is when we take TRF receiver, this super regenerative receiver has higher sensitivity in compared to the TRF receiver, right? How is that we can achieve this high sensitivity? How is that high sensitivity is achieved in super regenerative receiver? That is by providing a positive feedback at the input stage, right? I'll explain that very clearly, where in previous videos we know that we have different components of a receiver where you will have a tuned circuit that you will be receiving the signal and it will be sent to the tuned circuit, and then you will have different stages of amplifiers, right? And then you will have detector and then you will amplify that particular signal and start using it, right? This is the normal working of any particular receiver. And how was that high sensitivity is achieved in super regenerative receiver? That is by arresting the losses which is happening in the tuned circuit, right? It cancels the losses which is happening in the tuned circuit and make this particular receiver as a high Q factor, with a high Q factor, right? How it is done, like how we can achieve that particular thing is we can create a negative resistance. That is super heterodyne receiver, super regenerative receiver creates a negative resistance in this input stage, that is in the tuned circuit, so that it cancels the losses which just happens here, which obviously increases the Q factor. That is the main thing. But how is that a negative resistance is created? We already said that in amplifiers, right, we will limit the gain, especially when we use that in receiver. That's because too much of gain, that is a positive feedback, will create unwanted oscillations, right? Whereas in super regenerative receiver, we are going to use that as the principle of super regenerative receiver. That is, we will give a positive feedback here so that the positive feedback will create the oscillation, the required oscillation, and that oscillation will be quenched after a certain period of time, right? And this starting of oscillation and quenching the oscillation will be done very periodically, right? And this can be done by altering the bias voltage of the transistor. And this is how a negative resistance is getting created here, which increases the sensitivity of the super regenerative receiver, right? And because of this positive feedback, what happens? It creates oscillation. That is, it starts oscillation, and the oscillation will automatically stop when it reaches the bias cutoff, right? And this starting and quenching of oscillation can be controlled by the bias voltage to the transistor, whereas we can use a local oscillator to control that biasing voltage for this starting and quenching of oscillations, or else we can also use dynamic effects at the input stage of the super regenerative receiver, which is called as self-quenched. I will explain this in the circuit so that you can understand very clearly. Where you can see this is the super regenerative receiver construction, where you have two transistors here. As I said, we'll create a positive feedback at the input stage, right? And because of this positive feedback, it will cancel the losses which is happening in the tuned circuit, which increases the high sensitivity, right? And whenever you turn on any particular oscillator without any particular signal, right? You can see here we are using two transistors measured as A and B, and whenever the oscillator is turned on, right? You don't want to give any input signal. Whenever the oscillator is turned on, you will have some random noise, and because of that random noise, what will happen? The oscillation will get created, right? And the oscillation will continue until the oscillator reaches the bias cutoff. When it reaches bias cutoff, then this oscillation will be stopped, right? And until it is initiated by another positive feedback, it will not start the oscillation again, right? This is the normal working of any particular oscillator, right? Similarly, here we are doing the same thing. That as you can see here, this is the output when the signal is zero, when there is no signal, and this is when signal is present, right? As I said initially, whenever there is no signal, even though there is no signal, right, there will be an oscillation. The oscillation will start, right, and it will continue the oscillation, right? And as soon as the circuit is turned on, or whenever because of this oscillation, if it reaches the bias cutoff, then this oscillation will be quenched, right? And the same thing will happen when the signal is present. That is, whenever you give an input signal, right, it will create an oscillation and it will quench, right, and it will start again and it will quench. This starting and quenching of oscillation is same for both when signal is present and when signal is not present. That is for 0 and as well as for 1, right? The only difference is, you can see when the signal is present, the oscillation will start very early, but whereas here it will take some time, right? But the area covered in both the condition will be same, right? And the only difference here is the oscillation will start a bit earlier here, which increases the pulse rate when the signal is present, right? And whenever we need to find out the DC level, if you send this particular signal to the integrator or low pass filter, we will be able to obtain a high DC level for 1. That is when signal is present when compared to when signal is absent. That is because of the area under per unit time, right? So, and if needed, we can amplify that signal and we can use that particular data, right? This is the working of super regenerative operation, right? Remember, the other operations, detecting and obtaining the original data is same like previous receiver. The only thing is we are achieving higher sensitivity by giving a positive feedback at the input stage, which creates negative resistance and arrests the losses in the tuned circuit, right? So whatever I said, that is what I explained here. You can see here, like any oscillator which is turned on, initially it will start, and then whenever it reaches bias cutoff, the oscillation will stop, right? And this biasing, right, this building up and cutting off oscillation can happen at the rate of 100 to 500 kilohertz. And the same thing happens whenever the signal is present, but the oscillation will start little early, right? And because of that, if you use self-quench circuit, right, when the signal is present, right, each pulse will start early, that the oscillation raises the pulse rate when signal is present, right? And as I said, if we send the signal to the integrator or a low pass filter, we will obtain a high DC level for when signal is present for 1. right? Because it has more area under the envelope per unit time, right? And even though we have a lot of advantages for super regenerative receiver, that is, it is mostly used receiver for garage door openers, automatic garage door openers, and security systems, and it has high sensitivity when compared to other receivers. It is very inexpensive and it has minimum number of components. With all these advantages, right, and it is simplicity and sensitivity, it is replaced by super heterodyne receiver. You will see the working of super heterodyne receiver in next video, but this is replaced by super heterodyne receiver chips. That's because it has certain disadvantages, which is it radiates broadband noise centered on the nominal receiving frequency, and it has relatively broad bandwidth of several megahertz on UHF frequency, and because of that, what will happen is it will create interference. It is sensitive to interference, right? And the dynamic range is limited. And very important disadvantages, it is mainly suitable for ASK modulation when compared to other modulation, right? And that is why it is replaced by super heterodyne receiver chips, right? But this super regenerative receiver has higher sensitivity when compared to TRF or AHF receiver, right? So today what we have seen is we have seen the working of super regenerative receiver. I believe this video will be very useful for you. Thank you, my dear students.